Section 13.3 Contingency Tables Association. Some people call it two-way tables. Two-way tables, you can go horizontally or vertically. To start with this, we introduced this before, maybe back in chapter 4. So what we do is they give us, sometimes they give you a data and they want you to group them in a data. So that grouping method is kind of like you're trying to find the frequency for each set or each thing you're talking about, or specified in that within the problem. Maybe like they have a list of letters A, B, C, D. So they write A, comma B, C, 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 D, A, D. And then what you do, you group them in a way and form a table like this to show how many in each, how many letter has been repeated. But then here we talk about two variables, not just A, B, C, D. Here we're talking about the male, female, gender here, that's the gender. And then here the this provides us information about the colleges, like BUS for business, ANG for engineering, and so on and so forth. So here we have 4 male in the business and 7 female. 1 in the engineering, 1 male and 3 female. Then at last one, 2 male, 3 female. So the first thing we need to learn here is, how do we complete this table? How do we complete this table? All you have to do is just add horizontally. 4 plus 7 is 11, 1 plus 3 is 4, 2 plus 3 is 5. Vertically you get 4, 5, 6, 7, and here you get 13, 15, 20. That's the 20. That's how we start by completing the table. Now we are going to construct, so that's completing the table, determine what we call conditional distribution. Conditional distribution of the gender within each college, and we're going to find what we call marginal distribution. So conditional, that's within the body of the table, So how do you find conditional distribution? Well, the way this works is we are going to find, it says the gender per gender, so I'm going to go with the male first, with the male. And so in the business, how many males were in the business? We have 4 males divided by the total. And the total in the business, how many? We have 11 in the first row. So that gives us about 0.36364. For female, within the business, it was 7 female divided by the same total. So that's about 0.636. Okay, and then always here the total is the total in the business divided by the total, so it's going to be always 1. For the engineering, we do the same thing. For the engineering. So we go through, see how many we have in the engineering and fill that up. So it's 0.250 I got. For this one, 0.750, 0.400, 0.600. And then here, of course, 1. Now for the next part, how do we get this one there? So here is going to be always as well 1. But how do we get that one over there? We do the same thing. We look at the male. How many males in total we have? The males is 7. We have 7. 7 over the whole total, 20. So because we're dealing with total, 7 over 20, that gives us 0.35. How many females in total? We have 13. 13 divided by 20, that gives us 0.65. If you add them up, you see you're going to get 1, or you can say 20 divided by 20. So that's 1. So this, the content inside this part here, these are what we call conditional distribution. Conditional distributions. The ones within the highlighted region. Now the ones on the side, these are called marginal. distributions. They are in the margin, right? Margin of the table. Those are called marginal distributions. But notice the way we did it for, we found the conditional distribution of gender within each college. So we had to have a gender on the left side of the table. The genders on the left side. What about if they say the other way, like determine the conditional distribution of the college for each gender, so then you put the colleges on the left side. So here, determine the conditional distribution of the college within each gender. So that's the other way around. So whatever goes first, if they're asking for condition of the college, so the college goes first, goes in here. So now what we have to do is the same procedure. We're gonna go ahead and try to fill out the table the same way as we did earlier. So how do we start with this one? Is we go back to the original table. Okay. So what do we have to divide by here? We have, so to do this, let's go down to this table here. The way this works, let me put an arrow. So basically you always need, these entries can be found by taking how many are in the business and male. Let's call it BUS, business intersection with the male, like how many in both, divided by the total in the for the male, total male. So how many in the business and male in the original table? Here it's 4, and the total number of males is 7. So it's going to be 4 over 7, 4 over 7, which gives us about 0.5. Let me write it below it. 0.571. How many in the engineering? It's 1 in the engineering and male, 7. 0.143. The next one, how many here? 2 out of 7. That's 0.286. And if you add them up, you got 1. Okay, we do the same thing with the female, and I got these results: 0.538, 0.231, 0.231, and add up to 1. The total is, as we did before, if you remember how we did this, we took how many total men divided by the whole thing. So here, how many total in the business? In the business, we go back 11 divided by 20. 11 divided by 20. That's about 0.550. And we do the same thing here, 0.22, 0.200, 0.250, and this is 1. Okay, so this is the stuff inside again here. Those are the conditional distribution, and the other ones that I'm gonna frame it with red, those are the marginal. We call them non-conditional distribution. Non-conditional distribution. Okay, so that's important. Now the next thing, what's next? Well, we need to see before I move on to a new idea, is usually these things within the table that you draw. Let's say we draw a table like we have this table. These things that we have within the table called cells. Each one of this called cells. So these are the cells. Okay, cells. So if you have 2 rows and 3 columns, 2 rows, 3 columns, the total number of cells would be always their product, 2 times 3, 6 cells. In general, if it's like m by n, m rows, n columns, m times n, to give you the total. So the total number of observations that we can always get in any table is by either adding all the rows to get the top ones, as we did in the previous one. I added all the rows to get the 11, the 4, 5, or adding the columns, or you can say add the frequencies. This each number here, each one of those numbers, they represent the frequency. Those numbers here, the frequencies. So that's what this is. And now we have to see something called association between variables. So we have two variables of a population are associated if knowing the value of the variables impart information about the value of the other variables. Can some of the values of the variable impact or has any change on the other variables? Well, to see that, we're going to see which method can we use to check this out, to check if there's any association between the variables. Okay, and to do that, just think about association means they depend on each other, dependent, non-association independent. Well, one definition is variables can be associated if the conditional distributions are different. If the conditions, so means when you have the table and you look at the table, they're different. Here, in this case, if you look at the conditional distribution here, the conditional distribution, are they the same? Are they the same or are they different? So that's something we're gonna look at. Do we have a distribution? Do we have association between the variables? Well, so we can ask a question. Are the variables X and Y associated? Are they associated or not? Well, the answer here is no. In order for them to be associated, the entries, they have to be different. So the answer is no, since every conditional distribution of Y within X is identical. Do you see like the 0, 0, 2, 0, 0.2, 0.2, 0.5, 0.5, 0.3, 0.3? Do you see that? So that's what, because they are identical, you know, every conditional distribution of Y within X is identical. There's no association. They can be association if they are different. And keep in mind, as a note, for this kind of example here, the last one, we can't determine the marginal distribution. We can't find the marginal distribution of X. Why? Because we need the actual cell counts. Cell counts means, like, you know how they tell you the frequencies. Here they didn't give us the frequencies. They give us the they just give us the marginal distributions. That's why. So this example has not to do with the previous example. This shows to us that we can't determine the marginal distribution of X because we need the actual count of the cells, or the cell counts. So now remember, we told you we can determine the marginal distribution of X, like the vertical lines, but can we do it for the Y? Well, yes, only in this case, because these numbers or numbers or the decimals that we have in each row are the same. So in this case, if you want to find the marginal distribution for the Y's, each one would be 0.2, like the same row, whatever you have in the same row, the same one, 0.3, 0.3. And then if you add these up, you will see that it's 1. You will see it's 1. So originally, you know, when we have an actual data, like the first table that we have here, what we could do is to get the marginal distribution, you just take 11 divided by the total 20 to get the marginal distribution for this one. You take 4 divided by 20 and 5 divided by 20. That's how we got these numbers. But for this one, because we don't have the original count of each, we don't have the frequency. Since these numbers or these percents are the same along the rows, You can basically, because you have two of them, is if you take 0.2 plus 0.2 divided by 2, that will give you 0.2. And the same thing happened with the second row and the last row. But the columns, look at the entries in the columns, they are different. 0.2, 0.5, 0.3, they are different. That's why we can't determine or find the marginal distribution of X, but we can for Y. We can for Y. Now this one here, this talks about the association between the variables. You can read through it. No need to worry about the bar graph. And this is just another example on the left side where they give us the count. Here they use the to count here. This is 1. This represents 1 tallies. This is 4. This is 5. This is 3. So if you add the total across the the row, you will get 13. And then if you do the same, you get 18, 9, and then 6, 15, 12, and 7. If you add the last column or last row, you get the total 40. So do you see how they bolded the middle part? That bolded table, this whole table is called contingency table or two-way tables. And those bolded part, that's the conditional distribution that we use that to find the conditional distribution. And again, how do you find it? It depends. Here you divide 1 divided by the total 6, which is this. 4 divided by 6, you get this one. And 1 divided by 6, again, you get this. And you do the same thing for all the other columns. To get the last one here, we divide 13 by 40 by the total. 18 divided by 40, that gives you this. 9 divided by 40, it gives you this. Now this part here, those are the conditional distribution, and the other ones are the marginal. So that's what they're doing here in this question. What else we have? I think that's it.